Good morning, good day, good evening. I am Andrei Kuryan. Within framework of trees ontology, we, together with Kuryan Rubin, conducted a study of the concept initial problem situation or invention situation, as it call it in classical trees. In traditional engineering disciplines, we can see the difference between the new system design and problem-solving approaches. And this difference we can find in different models and tools and techniques that engineers are using to these approaches. The TRIZ model ontology developed and presented on the last TRIZ summit conference in 2021 show us that the new system design and the problem solving of the system in the system, are two general ways of system evolution from the state as is to the state to be. The initial problem situation is refers to problem solving approach. The goal of our study is to define the ontological relationships between different concepts like initial problem situation, requirements, system, and other concepts related to them. And we discussed this approach with Nikolai Khomenko, Nikolai Shpakovsky. Nikolai Khomenko made the model that connects.
Andrei, sorry for interrupting. Are you switching the slides or?
Yeah, sure.
We are, yeah, please.
Okay. Nikolai Khomenko used this approach to integrate system design and problem solving in his model, OTSM-TRIZ model, but we are focusing on the ontological relationships. Okay, the short review of requirements in engineering. When we are looking to the process of new system design, we're starting from requirements. And there are two different types of requirements in engineering. First of all is so-called stakeholders requirements, including requirements of customer. And the other type of requirements are requirements to the system, or system requirements, functional and non-functional. On the level of the stakeholders requirements, the engineer considers the system as a black box without understanding the structure of the system, functions of the system, and so on. On the level of the system requirements, engineer understands the structure of the system and understands how the components of the structure addresses to functional or non-functional requirements. And in this picture of requirements, the problem is out of the requirements. In order to find, analyze, and solve problems in the system, engineers are using different approaches. You can see examples of these approaches: FMEA, theory of constraints, Six Sigma, engineering design process includes special tools and techniques to find, analyze, and solve problems. What about trees? In trees, in trees, we can start from model of trees. And according to this model, problem is a kind of stakeholders requirements. And in trees, stakeholders requirements we call super system requirements. Another difference of trees approach is that when we downsize to system requirements and then to the structure of system under design, then we represent the system not as a set of components, but as a set of solutions where each solution could implement functional or not functional requirements. Solution could cause a problem. A problem is a requirement of stakeholder because a problem could recognize only a subject. Stakeholder, customer, maybe business people, and so on. And it is very interesting point because in trees we are operating with other representation of the system, not the structure of the system, not as a component, not a structure that could be decomposed on components, but the structure that could be decomposed on solutions. It's very interesting topic for future research in trees. Based on this analysis, we developed ontology of requirements in trees. You can see here we combined concepts from traditional engineering domains. These concepts outlined by as blue origins, and we added to this ontology concepts used by trees in problem solving. You can see that initial problem and new problem or secondary problem here are a kind of requirements, and other important component solution. It is a part of the system, and solution could eliminate initial problem and could cause new problem in the system. Based on this ontology, we developed the ontology of two types of contradictions in trees. First type of contradiction is called administrative contradiction, and you can see that administrative contradiction could be represented as an unknown solution that could implement requirement, functional or non-functional requirement. From the other hand, unknown solution could eliminate some initial problem detected in the system. Take please into account that solution is unknown in contradiction, and when we specify this, we will specify this solution, we can transit from initial problem situation to contradiction requirements. Solution in this contradiction is specified. We know this solution, and this solution implements some requirements, one or several requirements, and this solution causes a new problem in the system. Here you can see the example of these two types of contradiction. For example, we have the requirement to increase the protection of colonists from space radiation in the spaceship during the flight to Mars. Today we don't know the known solution how to make this defense efficiently. And this is the initial problem situation. We can analyze existing solutions and can select, for example, the solution when spaceship body could be produced from plumbum. In this case, we will implement our requirement. We will increase protection of colonists, but from the other hand, we will face with problems related to unacceptable increase of the spaceship launch weights. Here you can see different types of initial problem situation. Initial problem situation could be analyzed, and we can find the way that it could be eliminated by clarification of initial requirements. It is a typical situation when analysis of requirements will pass to situation when we haven't any problem in the initial problem situation. The other type of initial problem situation is situation when we can find the known solution that will implement our requirements or that will solve the initial problem in the situation and will not cause any secondary problems. It is typical situation as well, and very often we can face with this situation. For trees, it is very interesting situation when we can get from the initial problem situation the contradiction in requirements. And the previous example demonstrates this situation. Requirements, we can consider requirements as a system, a set of requirements, relationships between different types of requirements could be considered as a system called system of requirements. This system includes requirements from super system, neighbor systems, system requirements from the system under consideration, and as Therese recommends us to look to situation as to the system, this system could evaluate according to laws and regularities of system evolution. Not evaluate, could evolve according to the regularities of system evolution from trees. So we can analyze how requirements looked like in past and how they will look like in the future. This system approach is recommended to look to the requirements. During initial problem situation analysis, we studied different versions of arrays. The powerful tool allows us to solve problem. You can see here versions of arrays under our study. And on the right column, you can see components detected in RDS versions that describes the initial problem situation in these versions of RDS. Based on this list of components, we developed the technique that allows us to create initial problem situation definition, analyze it, and measure the different KPIs of this process. Before I present this technique, let's look three examples. Based on these examples, I will present our techniques. The first example is about the grinding wheel that does not work well on the complex shapes with depression and buggles. So, for example, for spoons. Replacing grinding with another type of processing is unprofitable or maybe difficult. The use of lapping ice ingredients wheels is too expensive in this case. And here is the example of initial problem situation. Example 2 is about IT companies that are trying to create more unique products to attract new customers and increase current sales. But a new product costs a lot of money. What to do? And the third situation is about ones are selling this plaster and the skin doesn't not brace how to do. Looks like a contradiction in requirements. And here you can see the table. On the first column of this table, you can see a list of components for definition of initial problem situation, object matrix, super systems, requirement, and so on. In three right columns, you can see our examples. And for each example, for each component, we can define the score from 1 to 5. 1 means that component is not defined. 2 means that not enough information about this component of the initial problem situation. 3 means a lot of uncertain information. 4, a lot of non-systematic information. 3 and 4 points are about the information overload. And 5, this means that the component of initial problem situation is defined correctly. This approach allows us to visualize the definition of initial problem situation. And in a simple way, we can see in what parts of initial problem situation definition the problem situation defined well, and where we have skipped information, or maybe wrong information, or maybe information overload, and so on. For example 1, the average score 54 percentages, for example 2, 28, and for example 3, we have 16%. This approach implemented in the application named component trees. Here you can see screenshot from this application. Kuryan Rubin, my colleague, can answer your questions about this component trees, we recommend this application not only for processing the initial problem station. This tool could be used for studying trees, for assessment of trees knowledge, and for practical work with real problems in during system design or system improvement. Resume. We started from the differences between concepts used in traditional engineering disciplines and in problem solving, such as requirement, inventor problem, solution, system, and so on. We proposed a general ontology for definition of initial problem situation that joins these concepts and applied joins these concepts from engineering disciplines and from trees, and we proposed a combination of system design and problem solving in one approach. And we proposed a method for formulation of initial problem situation in a formal way, and numerical evaluation and verification of the initial problem situation. Thank you very much for your attention, and I think we have some time to answer the questions.
Yes, Andrew, thank you very much for your presentation. It seems it was very clear and understandable by the audience. Very small questions here. We have a question from Andrew to Andrew. Приложение по обработке и анализу требований есть в тестовом доступе? Как его можно получить?
Yes. The question is about the access to the application component trees. Yes, I think we will share access to component trees after this conference to the demo version of this application. Okay.
I think here could be mentioned that this interface tool. Yeah. Just one second.
This is my co-author, Mikhail Rubin.
Yeah. Yes, Mikhail, please.
Значит, доступ к Component Trees открытый, он сейчас есть. И единственное, что там этот модуль, о котором сейчас идет речь, он уточняется и редактируется. В чат я брошу прямой адрес на Component Trees.
Okay. We will share.
One more thing, that this interface or software package needs the user to have account in Gmail, right? To register in it. Andrew?
Yeah. Could you repeat, please?
I mean, to use this application Component Trees, the user has to have account on Gmail, right?
Yes, Mikhail published the link. No, it is not Mikhail, Andrei Belyakov. We will publish a link, and we will present the instructions how to register and how to get access to component trees. Okay.